of the investigation. So let's look at section B. First of all, for section B, you need to make sure your model is the same as previously. So we need to be in the format KABX plus C. So I'm going to change some of the variables on Desmos to match this. KABX plus C. And let's just make sure we double check with the actual investigation. Let's double check KABX plus C. Excellent. So it says what we want to do is to make it 3x plus 2. And I'm going to change this up a bit. I'm going to say, rather than it being 3x plus 2, I'm going to just show you a similar but different example. So pasting this here, let's change this to 4x plus 3. So to get this to be 4x plus 3, we need A to be 4. And we need C to be 3. And we need B to be 1, like K. Basically, K and B will be 1 because this will give us 1 times 4 to the power of 1x plus 3. So this now matches my imaginary function. Remember, do not use this function. You want to use this function. It's given in section A. Now, continuing, it says, leaving all the variables the same, what happens when you change A? Then we're going to change K. Then we're going to change B. A, K, and B. So this is to questions 3, 4, and 5, or 2, 3, and 4. A, K, and B. So what you're going to do is you're going to talk about what happens when you change A. What is the particular important number when it changes direction, for example? K, what happens here? And last but not least, once you've changed K, here we go. And remember, you've got to set them all back to normal once you've finished. And finally, we are going to do B. What happens when you change B? And you need to describe in words what is happening. Now, you could look up on the internet how to explain it in an exponential graph, or you could just use your words in terms of the shape of the graph, trying to be quite formal rather than informal in your language. And the last thing you do is C. And this is what you're going to talk about, the general shape, that's using your own words, the y-intercept, you know what that is. And the horizontal asymptote is effectively what number does it tend towards but never touches. Basically, it tends towards 3, but it never quite touches 3. And you might be able to work out, well, where does the y-intercept come from looking at these numbers? And where does the horizontal asymptote come from? And you might be able to come to a conclusion on that. Part C, it says to draw these on line paper. Now, I don't mind if you do these on Desmos, and the way you do multiple graphs on the same grid, what you do is you expand it. We're going to take everything away. And I'm going to just go for 3, let's say 3 to the power of x. And we're going to get rid of everything else. There we go, there is our graph, easy peasy. Then we're going to copy it using Control C, paste it several times, and then you can easily change these values. And you can layer them on top of each other so you can see what is happening when you're adding more. So for section C, I don't mind you doing that without line paper. However, if you're doing it on Desmos, please at the end of each section explain what's going on. Part D, you're going to specifically talk about the combination of K and C. So you're going to add together K and C together in our previous example. And part 12, you are going to fill in what is A, K, B, C, y-intercept asymptote. It's like reversing substitution, and then you're going to probably analyse what you found in 11 with this particular table. Hope that is useful to you.